Hi everyone, welcome back. So hopefully you've had a chance to have a look at the person agent class within the code that you've written and get a good sense about what that's doing. So now we need to write the other class within our model, which is the model class, and the model is going to define uh, how all of the model sort of comes together, how the agents are controlled, how the environment works, and generally controlling how the model itself works. So we're going to write this as a class, which again means the first thing we need to specify is a constructor, our constructor function. Um, in our constructor function, we're going to need to set up the number of agents that we want in our model, the grid, the environment that they're going to live in, a schedule, which will determine the order in which agents act in each time step, and the starting cells for the agents where they're going to start in our model. Now, quick question for you just to have a little think about. Why might the schedule, which determines the order in which agents can act, be important? Just pause the video briefly and have a quick think about why that might be important. So, if we think about why that might be important in our particular model here, remember that we are creating a model in which agents are both moving and infecting. The order in which agents move is going to potentially affect things, because let's imagine we've got an agent in a cell and they are not infected, and in the neighbouring cell we've got an agent who is infected. If the agent who is infected in the neighbouring cell were to act first and were to move in to the cell where the non-infected person is, then that agent who's not infected could then become infected. On the other hand, if the agent who's not infected were to move first, they could then move out of that cell and never be infected, never be in that situation where the infected agent moved into the same cell as them. So the order in which agents act is going to be important. It won't always be important in all simulations, but particularly for this simulation, it is really important. So here's the model class. Here's what we're going to write for our model class, and here's the constructor for the model class. So we're going to call our model class disease model. So I've written class disease underscore model, and again we're going to pass into the input the model class of MESA. So our one thing worth pointing out here, you'll see that we've got. You'll remember we talked about there's a type of comment where you have 3 quotation marks. And that we see it in green here in Spider. This is actually quite important in MESA. If we put something within the model class here using our 3 quotation mark comment style, this will actually get put onto our server as we display it. So we can use this to display a sort of message to the user describing the model. So I've just put a simple message here saying a model of disease spread for training purposes only. But worth remembering that it'll actually take that comment and actually put that onto your visualization of the model. So here's our constructor. The things we're going to need to pass into the constructor as well as itself is n. N represents the number of agents in the model. We're going to need to specify a width and height of the model in terms of the number of cells, how many cells wide, how many cells high. The initial infection, which is the probability that agents are infected at the start of the model. The transmissibility, the probability that an agent passes on their infection to another agent. The level of movement, which remember is the probability that any agent moves within each time step of the model, and the mean length of disease, as we've discussed before. So those are the things that are passed in, because those are the things that some of those will then in turn be passed onto the agents. Remember, we set some of these things up in the agent constructor. They're being passed in here because they're going to be passed in from the user interface. So they're going to be passed into the model, and then some of them will be passed in turn to the agent class. The first thing we set up here, self.running equals true. Don't worry about that for a moment. It's going to be required when we come on to batch running at the end. So just for now, just set that to true. It just declares that the model is in a state of running. So we want to set up the number of agents. So we're going to say self.numAgents. That's going to store the number of agents we've got in our model. And remember, that's n. That's the value that we've passed into the constructor. Self.grid. This is where we set up the grid, the environment for the model. And remember, we imported something right at the start called a multi-grid in our list of imports, which basically means this is a grid in which more than one agent can be in the same cell. We want that for our model. So our grid is going to be a multi-grid. It's a class multi-grid. The three inputs to that are the width and height that we're passing into the constructor, the model constructor. So that's going to be passed in from the user interface. That's the number of cells wide and high. And the third one, true, determines whether the grid is toroidal. That basically means if a grid is toroidal, it means that if you're at the edge of a grid, say you're at the right-hand edge of a grid and the agent then moves right, they will then appear on the left-hand side of the grid. A bit like Pac-Man. It's that. A toroidal shape is one that sort of wraps around on itself. So it basically means you can move off the right and appear on the left, and similarly, if you move off the top, it'll appear at the bottom, and vice versa. So we want that for we don't want sort of edge effects on our model. We want them to be able to move in a toroidal format. We also need to set up a scheduler. Remember, we said that the order in which agents will have their turn to move and interact and behave is going to be important. We're just going to set it up using a random activation scheduler here. So basically, it'll just pick a random order for agents to behave. In the absence of any other information, that's going to be the best thing that we can put in here, because we don't know, we don't have any way in which we should determine the order in which agents should move. And it would be better to randomly activate them here than to say go through in order of their agent ID, because that means that the people with lower agent IDs would also always get the upper hand of being able to move and interact first. So once we've set up those things, we then tell the disease model class to then start creating agents. So we use a for loop, and we say to do this for the go around the for loop for the number of agents that we specify. So if we've got 100 agents in the model, then to do this 100 times. And remember, we've already got that stored in ourselves as num agents. And then for each of those iterations of the loop, we're going to create a new agent with an ID taken from the for loop. So the first agent will get an ID of 0, second agent ID of 1, third agent ID of 2, etc. We'll just use that to give our agent IDs. But we're setting up our person agent with all the things that we said the person agent needs. These are the things we specified in the constructor that need to be passed into the person agent constructor. So we're going to set up a person agent. I is going to be our ID. So that's I, that's the current counter in the loop. Itself, which is the model. Remember, we said that the model, if you look at your person agent constructor, you'll see that the model was the second thing we had to pass in. With that, in this case, we're in the model, so that's itself that is being passed into the agent. And then all of the things we talked about, the initial infection, transmissibility, level of movement, mean length of disease, etc. Once the agent's been created, we then need to add the agent to what's called the schedule. I remember we set up the schedule up here to say it's a random activation schedule. We need to add this newly created agent to the model's scheduler, which is a random activation where they'll randomly decide which agent goes next. When we say random activation, incidentally, in each time step, all of the agents will act. So it'll randomly determine the order in which they act, but they'll all act before moving on to the next time step. So we're going to use schedule.add to add our newly created agent to that schedule. We then need to decide where that agent's going to be located in our grid. The way I've set it up here is ideally I want the agents to be in their own cells at the start, if possible, to spread them out as much as possible at the start. I've just made that decision. So I'm using a try except statement. Remember, we talked about try except to sort of catch errors, to try doing something, and then if it doesn't work, to run the code in except. So what I'm going to do here, what this code is basically saying is, we can use the find empty function of the grid library, and that will find an empty cell at random within the grid. So allocate that as the start cell. Pick a empty cell at random, and then we can use the place agent function of the grid library to then place that our newly created agent in that empty cell. So, and the only things we need to pass into that function are the agent, which we just created, agent A, which we created above, and the cell that we've picked, the empty random empty cell that we've picked off above. However, it's possible that depending on the number of agents and the size of our grid, that there may not be any empty cells, so that would then throw up an error. So we can use the except statement to catch that and say, okay, well, if you didn't find any empty cells, then what I'm going to do, I'm just going to get you to pick a cell at random, any of the cells. They'll all be occupied if that happens. Just pick one. So I'm going to randomly pick some x and y coordinates using the function randRange of the random library. That basically says take a random number up to the number of cells in the width and the height. So if it's 10 by 10, pick a random x value up to 10 for both width and height, and then place the agent in the cell with those coordinates. So that we're using the place agent function, passing in the agent, but in this case, rather than the start cell that we picked up above, we're now saying here, put it at the cell with these coordinates, x and y coordinates. So pause the video now, write out this, you'll start writing your disease model class with this constructor function. And then once you've done that, just have a look back through just to make sure that you fully understand what's going on there. Okay, so hopefully you've had a chance to write that now, and you've got a better understanding of what's going on in the model constructor. So we need to write another function in the model class, and as with the agent, we need to write a step function. And again, as with we did with the agent, the step function is going to define what the model needs to do at each time step. Now, in this model, all we need the step function to do is basically just step forward the schedule, i.e. activate the step function within each agent according to the schedule that we selected. And in our schedule, remember, we've selected a random activation schedule. So basically pick an agent at random and then run that agent's step function. And then do that for all of the agents in the model, and then move on to the next time step. So this piece of code at the bottom is the entirety of our step function for the model, and it just tells the scheduler to step through and step through the schedule in that way. So just pause the video while you write that little function out. So we've actually now written the model file for the moment. We're going to add some bits to it later, but for now we've actually completed the model file. So actually there wasn't too much to do to create our model here. So the next thing we need to do is to write our run file. Remember we said that we'll need a run file, and that's the thing that's actually going to run the model. And remember we said that the run file will either run the model as a single run or as a batch run, or it'll use a server to visualize the model so we can watch it run live. And that's what we're going to do in this case. We're going to set up a server so that we can run the model live and watch what happens. The good news is this makes the run file really easy, because we just need to tell it to launch a server, and then we'll do all of the server stuff in the server file. So I want you to open a brand new .py file, a new tab in Spider. Save this one as disease_run.py. And the entire code for this file is these three lines of code that you see on the screen here. So the first one says from disease server, which is what we haven't written yet. That's the server file, but we're going to write it in a second. From that, import server, and we're then just going to set up the port for the server. Server.port equals 8521, and then tell the server to launch using the launch function of the server. We can write the same three lines of code whenever we do this. So the port will always be 8521. So you don't have to worry too much about this. If you're going to run your agent-based model as in a server view, you can just write this and obviously just replace your disease server with whatever you've called your server file if you're writing a different model. But these three lines of code are all you need. So pause the video while you write that. So the next thing we need to do is to write the last of the three files, which is the server file, because we need this because we said that we're going to write a server file so that we can watch the model run live. So again, open a new .py file, a new tab in Spider. Save this one as disease_server.py. So the first thing we need to do, as with any Python file, is to import the libraries we need. So here we're going to import these libraries on the screen, so I'll just talk you through them briefly first. So you'll see the first one, we say from disease_model, that's the model file that we've just written. And from that, we want to import disease model, that's our disease model class. So the model class that we've just written, that's what we're going to import. We then need to import some visualization aspects. So the second one, MESA.visualization.modules. From that, we want to import something called a canvas grid. That basically allows us to draw the grid on the screen. The next one from MESA.visualization.modular visualization import modular server. That's the type of server we're going to use to draw this visualization. And the last one from MESA.visualization.userParam import user settable parameter. The user settable parameter class allows us to use things like sliders to allow the user to play around with the parameter values to see how they affect the model. So those are the imports we're going to need for the moment in the server file. So pause the video while you write those out. So first thing we need to do in the server file is to write something called a portrayal function. And a portrayal function basically just defines how each of the agents are going to be visualized in our model on our server. So we're going to set it up, our visualization, so that it's visualized on a grid, and our agents are represented as little filled circles with a radius of 0.5, and they get coloured red if they're infected, and if they're not infected, then we represent them as smaller circles with a radius of 0.2, and they're coloured grey. So we'll have big red circles for those who are infected and little grey circles for those who aren't infected. And the layer value basically determines which ones should go on top if there's more than one in a cell, with a higher value for the layer, meaning that it's got higher priority, higher value, so it therefore goes on top. So if we just talk through this function, the agent portrayer function, we pass in the agent that we're going to portray. We're then going to set up a dictionary which represents our portrayal. So remember we talked about dictionaries before. We use the curly brackets to do that, and we have pairs of labels and values. So in this case we have a label called shape, which determines the shape in which agents should be portrayed, and the value for this is circle. We want them represented as circles. We have a label called filled, which basically indicates whether they're filled circles or not. And we do want them as filled circles, so that's going to have a value of true. And the default size we want for our agents, the radius is 0.5. Our label is 0.5. So then we can that's our default setup for an agent. We can then specify how we want the visualization to be different depending on whether they're infected or not infected. So we can say if the agent.infected is true, then we're going to change the color label of the dictionary. Portrayal, remember, is a dictionary. So we're going to set color to red, and we're going to set the layer to 0. Otherwise, if they're not infected, then we'll set the color to grey. We'll set the layer to 1, so they're higher up, and we'll make them smaller with a radius of 0.2. And then at the end of this function, we just simply return the portrayal, the dictionary that's going to be used to portray these values. So pause the video and write out your agent portrayer function. Just double check that you understand everything that's going on there. Once you've done that, we'll move on. So the next thing we need to do is we need to set up the elements that are going to make up our visualization. So for now, we're just going to set up one, which is going to be a grid, and that grid's going to contain, represent our environment. It's going to contain all the agents that are portrayed in the manner we've just specified in the portrayal function. And the grid's going to have 10 by 10 cells, and it's going to be of size 500 by 500 pixels. So that determines the size it'll be on the screen. So all we need to do this is just to set up a new grid of type canvas grid. Remember, we imported the canvas grid class at the start of this file. And then into that, for the inputs, we just need to specify the type of portrayal within that grid, which is the portrayal we've just set up, which we called agent portrayal. So how the agents are going to be portrayed. And then the size of the grid in width and height in terms of cells, and then in terms of pixels, so 10 by 10 and 500 by 500. So pause the video and write that bit out. So now we've got a grid set up, and we've specified how we want our agents to be portrayed. Great feature about MESA is it allows us to really easily add a user interface that allows those users to change those parameter values and see how they impact the model. So what we're going to do is we're going to add 5 sliders in our user interface that allow the user to change total number of agents in our model, number of people, the probability that an agent is infected at the start of the model, the transmissibility of the disease, remember that's the probability that an agent infects another agent at each time step, the level of movement, which remember is the probability that an agent moves at each time step, and the mean length of the disease in days, which or in time units, but we'll be using time units here to represent days. So those are the 5 things we're going to allow the user to change. We're going to have little sliders that the user can then play around with to change those things. And we can do this really easily. So basically, for each user settable parameter, we just specify the type of user settable parameter, and we're just going to use sliders in this case, so there'll be sliders on each one. The text that we want for the label on that slider, the default value for that value, so if it's number of agents, the number of agents we want as the default. The minimum value will allow the user to set, the maximum value will allow the user to set, and the increment of the slider. So each notch on the slider, how much does that increment or decrement the value in question. So if we look here, we've got the 5 sliders. So the first one I've called the number of agents slider, and I'm saying that's a user settable parameter, and it's of type slider. I want a label that says this slider represents the number of agents. Then I want the default value to be the 20 agents in the model, so the user doesn't change it, there'll be 20 agents in our model. I want the minimum value to be 2. It'd be pretty pointless to have an infection model where you only had 1 agent in the model, so you'd need at least another agent. I'm going to allow up to 100 agents to be specified by the user, and an increment of 1. And we need these to be whole numbers because we can't have half agents. We need them to be whole number agents. Similarly, the next one, for the probability of initial infection, we're going to have a default value of 0.3, so a 30% chance that each agent in the model is infected at the start. So 30% of them roughly should be infected at the start. And then a minimum value of 1% of them. A maximum value of 100%, because we can't have more than 100% of them infected. and the increment to the user can change to be in 1% increments. And the same goes for all of those. So pause the video now, write those out, and just make sure that you understand what each of those sliders that we're setting up are actually doing. So the final step in setting up our server, in setting up a server file, is to set up the server itself. So we specified all of the things that we need in order to set up the server: the portrayal, the way in which agents are going to be portrayed, what the grid's going to look like, the agents in which they'll be portrayed in, and the sliders, the user settable parameters, in this case 5 sliders that we want. That's all going to make up our nice little interface. So now we just need to set up the server in that way. So we specify the name of the model file that we want to use to run the model, which in this case is the disease model. Remember, we imported that at the start, our disease model we've written. The list of elements that we're going to visualize. So you can see here in square brackets we've got grid. It's a list because we can have more than one element. At the moment we've just got a grid, but we'll add more later. And remember, we've already set up the grid to contain the agent portrayal. We did that earlier. The title for our display, so disease spread model, that's going to be in the title of our browser. And then the sliders that we've set up. So the number of agents slider, the initial infection, transmissibility level of movement, etc. And you'll see here what we're doing is we're linking all of these to both to the variable name that we're going to be using. So N is the variable name that's then passed in to the disease model. And that, remember, represents the number of agents. So we're saying grab the value of N that's going to be passed into the constructor of the model file, disease model. Grab that from the value on the number of agents slider. So we set up the number of agents slider as being defaulting to 20, minimum of 2, max of 100. Whatever value the user selects there, grab that, take that as value N, and that's the value that will then be passed into the model. Same with the initial infection, transmissibility, etc. So write that out, pause the video while you do that, and then write out that. Make sure you understand what that's doing. So excitingly, we've now got everything we need to run our model. So what I want you to now to do is at the end of this video to run the model. What you need to do is you want to switch to the disease run.py file and run the code from there, either using F5 or push the green play button if you're in Spider. Run the model, and you should then see that your browser will then pop up, your internet browser. There may be a slight delay. You may get an error message come up in the console about a loop. Don't worry about that, that's normal. But after a short delay, you should get your browser pop up, and you should get something like this appear, where we actually see the model. And so if I just go out, and I'll just run it in mine a moment. So if we go out here, let's run the model. There we go. You see, so my model has popped up in my browser, and you can see here that we've got a grid set up with all of our agents that we've got in our model. Remember, we've defaulted to 20, so it will start with 20 agents. We've got some who are infected, represented as big red circles, some who aren't infected, represented as little grey circles. Because we've got fewer agents than cells, we've got 100 cells here, then each of them should be in a separate cell, because remember, we told it to try and put agents in separate cells at the start, and to only combine them if there weren't any empty cells left. Then on the left, you can see the various sliders that we've set up. So number of agents, I can change that between 2 and 100 as I set up. We've got probability of initial infection, transmissibility, level of movement, and mean length of disease up to 100 days. If you change any of those things, so let's say I change the number of agents to 50, I'll need to click the reset button at the top right in order for that to change to come into effect, and it'll reset the model with those new parameters. So if I then click Start up here, you can see the model starts to play out. and we can see people randomly moving around the model and starting to become infected, infect other people, etc. Now here I'm running it with relatively low levels of transmissibility and quite a short disease duration by default. So we're getting a little bit of infection, but quite quickly this disease looks like, and here we go, it's died out. So now that that disease has died out in our environment, we're not going to get any new infections. You can click stop, you can click the step button, it'll take you through one time step at a time. Have a play around with this. Try different levels of transmissibility, different lengths of duration for the disease, and see how that, remember you have to click reset each time, see how that affects the model and the number of people infected, etc. And see what happens to your models. Have a good play around with that for sort of 10-15 minutes, just to get a feel for how your model's working, and how actually you've managed to create quite a sophisticated agent-based model here using relatively little code. So once you've done that, play around 10-15 minutes, then we'll join you in the next video. So see you then.